We all know that digital computers change virtually every aspect of our lives. Well, the arrival of quantum computers could be even more historic than that. Quantum computing isn't on the horizon. It's already rewriting the rules of technology. In 2019, Google's Sycamore chip solved a problem in minutes that would take classical supercomputers DS years. That's not just impressive, it's historic. If you've heard the term quantum computing and brushed it off as sci-fi or irrelevant to your life, stick around. This isn't about futuristic labs or niche applications. Quantum computing is set to reshape industries, from healthcare and cybersecurity to finance and artificial intelligence. In this video, we're diving into how quantum computing works, the industries it's about to disrupt, and the global race to dominate the field. But that's not all. We'll also explore the hidden challenges holding it back, and why that won't stop it from going mainstream sooner than you think. Let's break it down without going too deep into the weeds. Traditional computers use bits, either 0 or 1, to process data. It's like flipping a light switch on or off. Simple and effective, but limited. Quantum computers, on the other hand, use qubits. Now, here's where things get wild. Qubits can exist as both 0 and 1 at the same time, thanks to a principle called superposition. Imagine flipping a coin. In classical computing, the coin lands on heads or tails. In quantum computing, the coin is spinning in mid-air, existing as both heads and tails until you observe it. This allows quantum computers to process multiple possibilities simultaneously, exponentially increasing their power. But that's just the start. Qubits can also become entangled. This means the state of one qubit is directly linked to the state of another, even across vast distances. Einstein famously referred to this as spooky action at a distance. It's like rolling a die in New York and another in Tokyo instantly shows the same result. This interconnectedness allows quantum computers to solve problems classical systems simply can't. Recent breakthroughs, including those from Google's team, show that increasing the number of qubits not only adds power, but reduces error rates, one of the biggest challenges. This isn't hypothetical anymore. The technology is advancing fast, and the race to unlock its full potential is heating up. So where will we see quantum computing's impact first? The truth is, this technology won't sit quietly in labs. It's already poised to transform some of the world's biggest industries. Let's start with cybersecurity. The encryption, protecting passwords, banking information, and sensitive data relies on mathematical problems that classical computers struggle to solve. But quantum computers? They could eventually break these encryptions, posing a significant risk to current security systems. Governments and tech companies are racing to develop quantum-resistant encryption to stay ahead of potential threats. While large-scale quantum computers capable of cracking today's encryption are still years away, the groundwork to secure data is being laid now. Next, healthcare. Drug discovery is an expensive, time-consuming process that relies on testing countless molecular combinations. Quantum computing could transform this by simulating molecular interactions with incredible accuracy. This means faster identification of effective compounds and reduced development times for new treatments. While we're not talking about overnight cures, quantum simulations can dramatically speed up the early stages of research, helping pharmaceutical companies develop drugs for complex diseases much faster. Finance is another industry watching quantum computing closely. Quantum algorithms excel at processing massive data sets, allowing for faster and more precise risk analysis, portfolio optimization, and fraud detection. Major financial institutions are already exploring how quantum tools can enhance market predictions and improve decision-making. And then there's artificial intelligence. Training large AI models can take weeks using classical computers. But quantum systems could significantly reduce this time. Faster processing means AI can handle more data, improving accuracy and enabling the development of more advanced models across industries. Finally, energy and material science are set to benefit enormously. Quantum computers can simulate atomic and molecular behavior, helping scientists design new materials, improve battery technologies, and develop superconductors long before they're physically built. This could drive innovations in renewable energy, and the potential is massive. While many applications are still in early development, progress is accelerating. The industries investing in quantum technologies now are laying the foundation for breakthroughs that will reshape the global economy. The race to dominate quantum computing isn't just a corporate competition, it's geopolitical. Nations are investing billions to ensure they're not left behind in what many are calling the new space race. The United States is leading the charge, with companies like Google, IBM, and Microsoft making massive strides. Google's Sycamore chip demonstrated quantum supremacy in 2019 by solving a problem that would take classical supercomputers years. IBM, meanwhile, has released a detailed roadmap suggesting that commercially viable quantum computers could be available by the early 2030s. China isn't far behind. The country has invested heavily in quantum research, with its scientists developing some of the most advanced quantum communication networks. In 2016, China launched the Matthews quantum satellite, successfully transmitting encrypted data over 1.2 kilometers, a groundbreaking feat that stunned the global scientific community. Australia has also joined the race, announcing a $1 billion investment to develop its first quantum computer. Meanwhile, Quebec, Canada is emerging as a global hub for quantum startups, attracting talent and fostering innovation that could rival advancements in the USA and China. Quantum supremacy, the point at which a quantum computer outperforms the best classical supercomputers, could shift the global balance of power. Nations and corporations that achieve it first will gain a significant edge in cybersecurity, finance, and beyond. But with all the excitement, it's important to recognize the obstacles. Quantum computers won't replace your laptop anytime soon. The technology is incredibly fragile and faces major engineering challenges. The biggest hurdle, qubit stability. Qubits are delicate and can be disrupted by even minor vibrations or temperature fluctuations. Most quantum computers must operate near absolute zero, colder than outer space, to keep qubits stable. Even then, they're prone to errors. If a single qubit falls out of alignment, entire calculations can fail. Scaling these systems is also a monumental task. Adding more qubits adds complexity, not just power. It requires precise entanglement and synchronization. It's not like stacking Lego blocks. Then there's cost. Quantum computers are extremely expensive to build and maintain. Cryogenic cooling systems, isolated environments. This limits access to elite labs and tech giants. Smaller companies and universities are often left out. Even if these challenges are overcome, practical applications remain narrow. Quantum computers excel at highly specific tasks, like optimization and cryptography. But large-scale, everyday use is still far off. That said, progress is real. Google is a more cheap EBNS roadmap, and other breakthroughs show that we're getting closer to useful, reliable quantum systems. Error rates are falling. Processors are getting stronger. The momentum is building. So, when will quantum computing go mainstream? Not tomorrow, but sooner than you might think. Experts predict mainstream adoption by the early 2030s. You won't have a quantum laptop at home, but industries like finance, logistics, and pharma will use hybrid models, combining classical and quantum systems for specialized tasks. In fact, this shift has already begun. Financial markets are testing quantum algorithms. Drug companies are running early simulations. The shift won't happen overnight, but the foundation is being built right now. Here's the takeaway: quantum computing isn't a distant dream. It's a technological shift that will reshape industries, economies, and daily life. Staying informed means staying ahead. Because the question isn't if quantum computing will reshape the world, it's when. And when that time comes, will we be ready? The answer might arrive faster than we expect. Sustainable technology.